Hi, everybody. It's Mr. Steger. Today I want to talk to you about temperature or the kinetic theory of matter and how is temperature related to kinetic energy. First of all, I want to do a brain check. Let's see where we are with things. You went through, hopefully, the first module. We're going to look at the second module and kind of see where things are. So with these following three statements, think to yourself, is this statement true or is this false? The first statement is solids and liquids are made of particles, but gases are made of air, which is not made of particles. Is that true or false? The second, kinetic energy is the energy of motion. Is that true or false? And lastly, kinetic energy depends on mass and speed. True or false? Okay, let's find out how we did. So solids and liquids are made of particles, but gases are made of air, which isn't made of particles. That's false. Air is made of particles. The particles aren't as close together. They're much more spread apart. If you think of driving down a car or driving in a car with a window rolled down and you stick your hand out the window, your hand's being forced back by particles of air. So it has force. It does have mass. Kinetic energy is the energy of motion. That's true. And kinetic energy depends on mass and speed is also true. So let's get into this a little bit. Kinetic theory of matter. Kinetic theory of matter. Matter is always moving. Matter is always made of atoms. Matter or atoms always move. That's essentially it. The addition of heat to matter increases the movement. And as we learned in our properties of matter, it can also change the state of the matter to go from a solid, liquid, or gas. Speaking of which, this is energy in action. So when you go from a solid to a liquid to a gas, the amount of energy in that matter, in that substance, is increasing. Solids like concrete, the atoms are close together. Think of them as being shoulder to shoulder. They don't move much at all. It takes energy to make them become liquid, like water. Water, think of a group of people that are sliding around. It's looser, they can move, maybe fall over each other, but they get up and they keep moving. So there's the possibility of flow, of movement back and forth. In gas, like air, matters much farther apart, and it's sprinting. Particles bump into each other now and then, but not much. So it takes up more space. Now, if we take energy away from gas, it condenses, it becomes a liquid. If we take more energy away, it solidifies into a solid. So adding energy and taking energy away from matter changes their states. Now, the temperature and the relationship of temperature to kinetic energy. Temperature is the average kinetic energy of particles in something. The molecules in something are always moving. You can't obviously take the temperature of each molecule or atom. Temperature takes the average of that substance or those molecules or atoms. The only time that molecules stop moving completely is at absolute zero. That's as cold as anything you get. We don't know if absolute zero has ever occurred. Scientists have tried to replicate it, but it doesn't happen because there's always heat from somewhere moving into the investigation. Now, the average kinetic energy of something as temperature is kind of abstract. So Mrs. Arts actually came up with a really good example, and I'm going to use this with you and share this with you. So keep in mind, kinetic energy is the movement of molecules or atoms in something. We already talked about that. Temperature is the average kinetic energy of matter. All right. Now, with that being said, let's pretend that in this photograph, every person is a molecule, is matter. Pretend that the age of each person in this photograph is heat. So each of these students has an age. That age represents heat. The averages of those ages of those people in that classroom is the temperature. So let's try this out on something. I've created a Google form, and we're going to take the temperature of the students in the energy unit in Create, and we're going to come up with the average. which will be the temperature. Okay. So the classroom example, I've got a form made simply asking you how old you are. Now the ages of people in Create are going to vary widely from the staff, from the teachers, myself, Mrs. Ars, Hopkins, Gerke, Haroon, Blaine, Meyer, to the youngest sixth grader that we have. What we'll do with this activity is enter your age, and then I've got a graph set up that we can use to get the temperature of the class, the average ages. So you'll find the links on the master page that I've got shared with you in Google Classroom. Take a minute, complete it, and we'll see what we get. Thanks.